Hello, and welcome to another edition of Math, Music, and More. Today we're actually going to jump into the world of finance and the applications of basic arithmetic into finance, and in particular focus on a specific type of thing called a perpetuity, which, as the name implies, is a series of regular frequent payments that go on ad infinitum. And it's actually going to be linked to an earlier video that I've already done in the past where I described the concept of synthetic division. And in fact, I never erased what I did back then in that video where I demonstrated that taking a ratio like x over 1 minus x is actually an infinite geometric sequence, x plus x squared plus x cubed plus x to the fourth, etc. And here in standard summary notation, when we represent a series and an infinite sum, we use the capital sigma to represent a sum, n equals 1 to infinity of x to the n equals x over 1 minus x. And that was the final result of that episode where we talked about synthetic division, what it is, and what are the interesting results of a given ratio that we could subject to such synthetic division. So I'm going to use this now to point out that this infinite sum equals x over 1 minus x. I'm going to use that information to actually evaluate this thing called a perpetuity. So let me erase some of this here quickly, but I'll leave that formula up for just a moment. And we'll think about a very, very simple perpetuity just to keep the math simple. And what would that be? Just getting $1. Let's say you pay for an investment where after 1 year you get $1. After 2 years you get $1 again. After 3 years you get $1 again, and so on and so forth to infinity. Then what you could say, obviously, is that here, if I let this be t, at t equals 0, 1, 2, 3, dot, 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 you get $1, you get $1 again, you get $1 again, you get $1 again, and so on. So I just wanted to show a quick visual representation of exactly what I'm talking about. So the question is, if someone were to offer you something like that, what would that actually be worth today? If I were to offer you a certain fixed lump sum of cash right now, what amount of money right now would have the same value as getting $1 at the end of every year ad infinitum? And here we get, of course, into the concept of the time value of money and hence interest rates. So let's think about interest rates. And again, I'll pick an easy one, 10% interest. If you have, for example, $100, then if you accrue it at 10% interest, well, then you have how much after a year? $110. It's literally just that you take what I'll call B for the beginning balance, and you just multiply it by 1 plus the interest rate, which in this case is 100 times 1 plus 0.10. So we're multiplying by 1.1. The 1 gives you back your $100. The 0.1 gives you that component of interest accrual over a single period. But think about it, when I'm doing this, I'm always just projecting values forward. What if I were to tell you that you're going to get $110 a year from now? How much is it worth today if the interest rate is 10%? Well, then obviously what you do is the inverse. You don't multiply by 1.1. Instead, you divide by 1.1 to get from here to there. So when you go forward in time, you multiply by 1.1, again, if the interest rate is 10%. And if you want to go back in time, it's you divide by 1.1. So this is where this annuity here of getting $1 at the end of every year becomes interesting. Because remember how we said to understand the value of $110 and it's a year away, you divide by 1.1? In other words, 1 plus the interest rate? Well, that would mean that 1 year out, we divide by 1.1. If it's 2 years out, we actually divide by 1.1 squared. And if it's 3 years out, it's dividing by 1.1 cubed. So notice how it's almost looking like the beginning of a geometric series, because dividing by 1.1 is the same thing as multiplying by 1 over 1.1. Dividing by 1.1 squared is the same thing as multiplying by 1 over 1.1 squared. And similarly here, times 1 over 1.1 cubed. And if I were to do this in general terms, each of these discount factors, so to speak, is equal to 1 over 1 plus I to the n, right? When you're 1 year out, you divide by 1 over 1 plus the interest rate. If it's 10%, it's 1.1, one time. If it's 2 years out, it's 2 times, etc., etc., etc. And notice, and this is why I use the notion of just getting $1, because it keeps the math then very simple. Because it means that if we erased for a moment getting a payment at t equals 0, let's say you don't get payments right away, you start getting payments a year out, 1 year out, then what is that actually worth? Hold on, I'm going to clean up a little bit here again. 1 year out, it's worth 1 over 1 plus I to the 1. 2 years out, it's worth 1 over 1 plus I to the 2. 3 years out, it's worth 1 over 1 plus I to the 3, and so on. This is where we make the leap back to synthetic division, because we realize that this was the equation of a geometric series that goes to infinity, where the value is just x. And we notice that this thing in the parentheses, 1 over 1 plus I, we could let that equal x. If we let that equal x, we could plug it into here, and we'll know exactly what the perpetuity is worth in today's dollars. So let's do that. If we have 1 over 1 plus I, and we divide it by 1 minus 1 over 1 plus I, what does that actually equal? Well, to start with, we have to normalize this here, so that in the denominator you have 1 plus I over 1 plus I minus 1 over 1 plus I, and then 1 over 1 plus I. If you look at this quickly, you can see that all the 1 plus i's kind of cancel. You have them here, you have them there, and you have them there. All of those basically cancel out. You can factor that out pretty easily. So what's left? You're left with a 1 up here, and 1 plus I minus 1. Well, what's 1 plus I minus 1? It's just I. So this whole thing simplifies to just 1 over I, the interest rate. That's it. And as we said a moment ago in our fictitious example, our hypothetical example, the interest rate was 0.1. Well, what's 1 divided by 0.1? $10. 1 divided by 0.1 would be $10. So in other words, if I were to tell you that the interest rate is 10%, and I give you $1 after every year, how much is it worth in cash right now? The present value in total? It's actually $10. And it makes sense, because if you were to invest $10 and get 10% every year, 10% after year gives you $1. You push that out as a payment. You reinvest the same $10 at 10%. You earn 10% interest. It's $1. You pay that out as well, and it goes out ad infinitum, and your $10 of capital are always tied up. I hope that made sense. This is where we're starting to bridge the mathematics of synthetic division into the notion of interest rates and the time value of money, and therefore how much annuities are even worth. And we're going to go into more detail in future episodes where we'll look at not just infinite series perpetuities, but also term loans. What if the loan is just for 30 years? Or it's a car loan and it's only for, I don't know, 36 months or 60 months or 48 months or whatever it might be. How would you actually go and calculate that? That's something we're actually going to tackle in a different video, because this one's already way too long. My apologies. Have a great day and see you next time.